All right, good morning. You're welcome to the YCAT Academy once again. So again, we are looking at organic synthesis this morning. Okay, and let's look at that. So generally, we have various natural products. Okay, so and most of these compounds they are regarded as secondary metabolites. Secondary metabolites. All right. So and specifically today, we just be looking at the synthesis of So we'll be looking at synthesis, in fact, chemical synthesis, okay, of mosaicisine, all right, from cholic acid. So we are interested in various steps, and mechanism involved in this. I'll move from one intermediate to the other until we get to the final product, and then all the necessary conditions that are attached, for the derivation of what kind of product or the other one, right? So let's take a look at that. So how do we go? So the structure of mosaicisine, is of a cholic acid is as follows. So this is what we call cholic acid. This cholic acid, so as you can see, is a tetracyclic compound. All right, it's a and then we have a kind of aliphatic chain right here. So consisting of 1, 2, 3, 4, 4 carbon. So we have a carboxylate group, which is characteristic of organic acids. All right. So and then when you look at this bond there, okay. So we might decide to number this, starting from here 1, 2. So, but the most important thing now is just the structure. And then we take cognizance of those various functional groups that are associated with this. So when you see a kind of wedge structure like this, it shows that actually this particular bond is a methyl group here. So it's pointing to me out of the plane. All right. And when you see such a kind of wedge structure drawn like this, it shows that this bond is pointing away from me. So this is coming out of the board towards me. So why this one is pointing away. So how do we go from here? So the very first thing we do is that we look for a way of acylating this hydroxyl functional group. Because at the end of the day, we are going to regenerate each of these hydroxyl group, all right, as we'll soon find out in our eventual product. All right, so as it is now, we'll cover them and protect them, from various other chemical reactions, maybe be it oxidation. As you know, an alcohol can be oxidized and so on and so forth. So now, and then we want to avoid that as much as possible. Then this carboxylate group here also want to get rid of this. So how do we go from here? So we move like this. All right, we go. All right, we make use of C2O. That's acid anhydride. That's a short form. You have pyridine. All right. Okay. So and then let's say proportion of about 90%. Is that okay? Of that is required. Okay. Then that is the first thing we do. So we treat this, with acid anhydride, pyridine, and then concentration, about 90% of it. That's okay. Then also we move on to we use we have to oxidize this, like I said. So we can make use of iodobenzene, diacetate. Okay, so and that will need a radiation, that's ultraviolet radiation. Is that okay? In the presence of iodine. Okay, actually we want to iodinate this group, so we want to get rid of this entire carboxylic group. All right, So, and then at the same time, the condition necessary, for this is at room temperature, all right? And then just about, you know, about 85 or 90, it's just 90%, okay, yeah. So this one actually taking place at 70 degrees centigrade. Is that okay? So that is all right. So now that is the condition. So we first of all treat this, then followed by this, and then we can be happy and generate our product. So don't forget at room temperature. So if we do that, then the result is this. That's not actually where we are going, all right? So, and as if that is not enough, okay? So having done that, okay, the next thing is that actually we oxidize this, okay, and get rid of this iodide, group, and then we obtain a kind of a keto group, at this junction. So how do we achieve that? So we can achieve that by making use of number one, we treat it with silver carbonate, okay? So silver carbonate, you know, in aqueous acetone, all of these are organic solvents, okay? So, and then at, the proportion, 90% concentration, so that we do. Then, as if that is not enough, secondly, we treat it with PCC, okay? PCC actually is pyridinium, all right? Pyridinium chlorochromate, okay? Actually is an oxidizing agent. Is that okay? We have used this again and again in oxidation of alcohols to aldehyde. Actually, it takes us one step further in oxidation. So actually, it's a mild oxidizing agent, so that we are careful not to oxidize beyond necessary. So in the presence of PCC, making use of dichloromethane, okay, as it were. So, and then treating it with 50% and 90%, of that solvent, of that combination respectively. So when we do so, the result we obtain is this. So we go from here and then we obtain this. We obtain this. So that's a keto group. I mean, the aldehydic group we obtain here. So that's a carbonite group. So with the function of it just to introduce a carbonite group here. So that's all. So don't forget, we have acylated each of those hydroxy group, as it were. So we obtain, all right. So we obtain this, all right. So don't forget the procedure, how we have gone, because if we don't go this way, actually you might get something else. Every condition matters. So take note of that. So if that is okay, all right, so the temperature also room temperature, so that suffices for that. So from here we move, and then now that we now have this, okay, then we need to extend this chain, all right. That is, I have 1 2 3, 3 carbon chain here. So I want to introduce another 3 carbon moiety here. So, and by so doing, I achieve that by making use of this reagent. I have this. So actually, this is a kind of benzoin derivative. So we have this, all right. So this is a cation, as you can know. So it has a counter ion here, which is an iodide group. So, and then, so we want to introduce this moiety 1 2 3, all right, into the product we have already obtained. And then that cannot be done without, lithium, you know, uh, you know, lithium butoxide, I mean butane. So this actually guy here is an organolithium compound. Is that okay? It's an organolithium compound. So, and that can be achieved, in the presence of tetrahydrofuran. So we have that. Okay. So we move. So from there. So and then at about 85%, of this actually we do. So if that is all right, then what we then obtain is this. So we have this. So don't forget we have introduced another 3 carbon, addition to what we started with earlier. All right. So, and in the course of that process, okay, so there's a shift, okay, from this group here to this portion. So this is what we end up with. So we have O A C. Don't forget we are C as we have highlighted everything there. So we have this. We have this. All right. Good. So that is what we obtain. Is that okay? So now, as if that is not enough, we can move from here. Now, we need to introduce a kind of a 6 carbon sugar moiety right in here. Okay. So and then, in fact, before that, yes. So we need to introduce that. So how do we go from here? So we come, to this junction. So what we just simply do is that we work on that, and then this is what we have. So we have we make use of the solvent. So that's okay. So that's Cl. Okay. Before then, let's even do this. We hydrolyze. All right. So when we hydrolyze that, okay, so in the presence of dioxane, good, all right, so we can now introduce actually the group we use, to cover up this one. Then before we introduce TMSO, into TMSO there, so let's see what we have. So we introduce NaOH, okay, so and that's in aqueous, methanol. All right, so about 90% is okay for that. So, but then immediately followed by, and then we reflux. Please note that refluxing means, just for some several hours, for us to achieve our products. And then at the same time, we make use of this species, that's Cl, CO to ET in a solvent. We call it dioxane. All right. So, and then we treat it with about 90%, of that. So by so doing, we achieve what we want to do. So for this one, actually, the necessary temperature, okay, is 0, because actually this particular organolithium compound, lithium butyl, yeah, or butyl lithium compound there is pyrophoric. Is that okay? So therefore, it has to be treated, at low temperature. So we test it at 0 degrees centigrade and then, 60 degree centigrade. So then we obtain this product. So maybe from here, so we'll continue and see how far we will go. So, but then in order to achieve this, so this, having done that, this is what we obtain. So we have this. The effect of the hydrolysis is what you see right now, alkaline hydrolysis. So turning each one of these groups actually to an hydroxyl group. So why actually we protect this one, using the species that we have just introduced. So we have about 2 or more steps. Is that okay? How we introduce TMSO SF. And then from that, we'll be able to achieve our product. So in the subsequent video, we'll see actually we can go from here to achieve our desired products. So I hope it makes sense to you. So watch out for the next video on this. So also don't forget, right from the point here, introducing this group. So this is what we have. So there's a double bond here. All right. So an alkene, functional group here. So an in group. All right. So don't forget that. So watch out for the next video for the rest of that.